Hello guys. So in the last two lectures we have started with the fifth unit. Okay, so we have studied the theory part of the torsion, and also we have solved the two sums, and also we have seen different terms in the torsion only. Okay, this is actually the first part in the fifth unit, which is torsion. We have seen the what is meant by sharp, different assumptions to derive a formula which is required to calculate different parameters in the torsion. Okay, so we have seen strength of the shaft is torque. Okay, this is most important formula. Tau by r is equal to T by J is equal to G theta by L. Okay, so this is most important formula. Okay, so tau by r is equal to T by J is equal to G theta by L. All terms in this equation are maximum shear stress, maximum radius, that is outer radius, maximum torque, polar moment of inertia, okay, shear modulus, angle of twist, the length of the shaft. Okay, so we have also seen the different formulates like power 2 pi and T mean by 60. Okay, here in this fifth unit you have to be careful in the unit system only. You have to convert forces in Newton, power in Newton meter, okay, Newton meter per second. Okay, and after that you have to convert the torque which we will get by this formula in Newton meter. You have to convert it in Newton mm. So by using that you can get the diameter in mm only, and you have to convert length in mm. Okay, so we have seen all these formulas: torsional stiffness, torsional flexibility, torsional rigidity. Okay, the different formulas for polar moment of inertia for solid shaft, it is pi by 32 d raised to 4, J is equal to pi by 32 d raised to 4. For hollow shaft, pi by 32 d o raised to 4 minus d I raised to 4. We have seen these two sums, okay, based on the design of the shaft, that is to determine the diameters of solid shaft, diameter of the hollow shaft, okay, and the angle of twist that will be developed in the shaft after application of the torque. Okay, we have also seen the weight of the shaft, how to calculate the weight of the shaft. So weight is nothing but mass into acceleration. So to convert, we can convert mass in density into volume, and density into, as we can write for volume, area into length. So we'll get formula for weight: density into area into length into acceleration due to gravity. Okay, so this is also a sum to calculate the dimensions of the shafts, that is inner diameter and the outer diameter. This is for hollow shaft only. So we have calculated the outer diameter and inner diameter. Okay, now we will see the next sums, right? Okay, so this is your next question. Compare weights of the solid and hollow shaft to transmit a given torque for same maximum stress. The inside diameter of the shaft is 3/4 of the outside. Okay, so we have to compare the weights of the solid shaft and hollow shafts. Okay, so what is given data? Just write the given data. Okay, the inside diameter of the shaft is 3/4 of the outside. Okay, for the same maximum stress. Okay, so as it is not given the relation between the length, okay, the torque transferred, hollow shaft to transmit a given torque. So that means okay, you can see in the question, the solid shaft and hollow shaft to transmit a given torque. So torque will be same on solid shaft and hollow shaft for the same maximum stress. So stress developed in the shaft will be shear stress. Okay, so torque and shear stress in the solid shaft and hollow shaft will be same. Okay, length of the shaft we will assume it as same. Okay, inner diameter is 3/4 of the outside, as it is given in a question. Okay, so we have to compare weight of the solid and weight of the hollow shaft, that we have to calculate. Okay, so we have already studied weight is nothing but mass into acceleration. Okay, right? So first we will calculate. So to determine this weight, we just need to get the relation between outer diameter and inner diameter first. Okay, as we know that we can take a ratio of polar moment of inertia of the hollow shaft and polar moment of inertia of the solid shaft, we will get pi by 32 do raised to 4 minus di raised to 4 upon do raised to pi by 32 do raised to 4. Okay, just putting the relation do raised to 4 and di raised to 4. Okay, so we'll get a ratio of the gh upon gs as di upon do raised to 4 will be 3/4 raised to 4. Okay, just see here, pi by 32 pi by 30 will get cancelled, do will go in this bracket, do will get cancelled, so 1 minus di raised to 4 upon do raised to 4 will be there. So we know that di upon do is 3/4, 3/4 raised to 4. So we'll get gh upon gs as 0.68 0.68539. Okay, so we know that weight of the solid shaft upon weight of the hollow shaft, okay, weight is nothing but density into volume into acceleration due to gravity. So that is mass into acceleration due to gravity. We can write for mass, density into volume. Volume is area into length. So rho al g will be there. So density as material is same, that maximum shear stress that we can transfer is same, that means material is also same. Okay, so density will be cancelled. Okay, length is also get cancelled, acceleration due to gravity will also get cancelled. Only there will be a ratio of area of the solid shaft upon area of the hollow shaft. Okay, so weight of the solid shaft upon weight of the hollow shaft will be pi by 4 ds raised to 4, that is area of the solid shaft, pi by 4 do raised to 4 minus di raised to 4. Okay, so weight of the hollow shaft upon weight of the solid shaft will be, we can write inversely, right, do square minus di square upon ds square. Okay, so just take a do outside. Okay, from this equation we can take do outside, so 1 minus di raised to 4 upon do square upon di square upon do square will be there. Okay, just we have taken outside is do square, so this is 1 minus di square upon do square upon ds square. Okay, we know that di upon do is 3/4, so 1 minus di upon 3/4 square. So weight of the hollow shaft upon weight of the solid shaft will be 7/16 do square minus do square divided by ds square. That will be your first question, first equation. Okay, so as it is given, as we can use the shear stress formula, tau s by r is equal to t by j. Okay, so we can write tau s by ts is equal to r by j. Okay, so by comparing the solid shaft, as we know that the shear stress and the torque on the both solid shaft and hollow shaft is same. Okay, so just we need to calculate this ratio, tau s upon ts. Okay, r is ds by 2 pi by 3 ds square ds raised to 4, ds by 2 pi by 32 ds raised to 4. Okay, so it will be 16 by pi ds cube. Getting my point? Just calculate here. Okay, similarly we can calculate for hollow shaft and you will get the relation 16 by so this is your equation, tau h by th is equal to 16 by pi do cube, and that will be 256 upon 175, 256 upon 175. So by comparing these two equations, okay, by comparing this equation, okay, by comparing this equation and this equation, okay, both are equal, as on the left side is equal, so right side will also equal. So ds cube upon do cube will be there, so you will get the ratio of ds upon do. By putting in the first equation, by putting this ratio in first equation, okay, you will get a ratio of wh upon ws, that is weight of the hollow shaft upon weight of the solid shaft, 7/16 for do by ds on 1.135 its square. So the ratio will be wh upon ws is 0.564. Okay, so how we did it? Okay, first we have found out the ratio of weight of the solid shaft, weight of the hollow shaft upon weight of the solid shaft. Okay, this is your first step. Second step, we have determined the ratio of the polar moment of inertias. Okay, ratio of the polar moment of inertia for hollow shaft and solid shaft. Then we have compared by using shear stress formula. Okay, tau by r is equal to T by J. So we have taken the same quantities for solid shaft and the same parameters for solid shaft and hollow shaft on the left side and other parameter on the right side. So tau s by Ts will get 16 by pi ds cube. Tau h by Th will get as this equation third. Okay, this equation third. Okay, 16 by pi d cube 256 upon 157 by equating these two value. Okay, so we will get the ratio of ds by dy, that is the ratio of solid shaft diameter upon outer diameter of the hollow shaft. Okay, so by putting in the first equation this ratio, you will get the ratio of the weight. Okay, so this is a complicated questions, but you have to solve it. Okay, the same type of question, all these questions are asked in university exams. Okay, these are typical, but these are very important questions. Okay.